Hi there, my name is Julia Olvera-Ryan, and today my group and I are going to be talking about lab safety. We recently conducted a lab experiment which requires knowledge on this matter, and for our presentation, my group and I will be talking about it. When beginning to conduct an experiment, there's a lot to learn about what symbols are on substances. GHS is a system that classifies and labels chemicals and their hazards. This is based on an internationally agreed upon standard managed by the United Nations. Here are a list of possible hazards: corrosive, environmental hazard, toxic, flammable, oxidizing, and health hazard. Other symbols not listed are moderate hazard, which looks like an exclamation point. This may cause irritation, redness, rash, and including it may cause damage to the ozone layer. It is best to avoid it with your eyes and skin. Secondly is the gas under pressure, and this symbol looks like a gas canister. When gas is released, it may be very cold, and the gas container may explode when heated. It is best to keep away from skin and eyes as well. Finally is explosive hazard, which looks like an exploding bomb. This indicates that it may explode if exposed to fire, heat, shock, or friction. It is best to avoid ignition sources and wear protective clothing. Overall, it is important to look out for these hazards for the safety of everyone and the individual performing the experiment.
A chemist can learn the health hazard, flammability, reactivity, and special hazards that a chemical may pose during a fire by consulting the NFPA diamond. This diamond is a visual representation that may be labeled on the chemical container and is categorized with numbers from 1 to 4, 4 generally representing the most hazardous measure. The blue diamond on the left represents health hazards, while the red measures fire hazard. For example, the number 0 shows that the chemical will not burn, while 4 is used to label very flammable gases or very volatile flammable liquids. Yellow may show the reactivity and stability of the chemical in the presence of water, high temperatures, and pressure. Finally, the white diamond at the bottom alarms the chemist of any other hazards to be wary of when handling the chemical.
Based on the GHS and NFPA classification systems, it's crucial to identify the safety hazard for each of the chemicals involved before performing an experiment. To successfully assess these risks associated with utilizing the chemicals, one must pay attention to the safety data sheets that will be provided for that specific chemical. In this example, we can see that the GHS and NFPA information about copper was included under hazard section of the safety data sheet as shown in red boxes. Based on these classifications, copper had pictograms that corresponded to it being a toxic, irritant, and a health hazard. Using the similar data sheets, we were able to identify each reactant's safety hazard as shown in the table here. From copper to zinc, each chemical formula had its corresponding NFPA diamond category from 1 to 4 for health, flammability, reactivity, and special hazards, and its specific GHS hazard. Since nitrogen dioxide and cupric nitrate safety data sheets indicated their oxidizing properties, that information was indicated under safety hazards. In conclusion, to minimize such hazards, we must look at the safety data sheets to obtain safety information before conducting an experiment.
When carrying out an experiment, not only is it important to inform yourself on the hazards of the chemicals, but it is also essential to know the potential hazards of any equipment you may use. The fume hood and the Bunsen burner are the two most dangerous tools in use during the experiment. To ensure the probability of accidents is lowered, make sure whenever the Bunsen burner is on, it is closely watched at all times, When the fume hood is required, the TA should take over when placing and removing materials from it. A few other basic safety rules include making sure everyone is wearing gloves, goggles, and a lab coat, better known as PPE. There should be no eating or drinking in the lab, and acknowledging exits and emergency equipment should be done before the experiment starts in case of an accident. Those are a few of the major yet simple rules that should be followed to ensure everyone's safety during the experiment.
In addition to being aware of the potential dangers of certain chemicals and equipment, the appropriate attire is crucial to upholding safety in the lab. It will not only protect the individual from harm, but can prevent major hazards from happening. So with that in mind, it is important to avoid loose clothing, open-toe shoes, jewelry, and clothing that reveals skin, all of which are potential dangers that can pose harm to the individual in the lab. For people with longer hair, it is crucial that hair be pulled back for the same reasons. Gloves and goggles must be worn at all times whenever handling hazardous chemicals, even in small quantities. There is always a small chance for potential spills and splashes of dangerous chemicals and explosions involving broken glass. For example, in this experiment, dangerous chemicals such as nitric acid and sodium hydroxide are used, and so use of safety attire is important for protection. Additionally, when heating glassware during this experiment, goggles and gloves should be worn to protect against potential explosions involving broken glass. It is also important to frequently change gloves to avoid cross-contamination, and when doing so, to properly dispose of them and change them correctly. Wearing safety attire adds a protective layer to minimize damage and is an important precautionary measure that promotes safety in the lab. Additional personal protective equipment may be necessary as well and should be selected based on the hazards of your work. In short, it is important to remember to prioritize and uphold safety, as well as to recognize proper safety measures in the lab to not pose any danger to ourselves or other people in the vicinity. Thank you.